Let's take a look at this problem, problem 4. So let's identify, it says, from the graph, state the intervals on which G is continuous. And I'm going to just ask you, for example, what type of discontinuity is it? -2.
Movable?
No, it is a jump.
That's not a point? Oh, no, you're right, you're right.
The limit from the left has to equal the limit from the right, and it does not. Okay, what about the 2?
So what does that mean?
That'd be another jump.
Jump. What about at 4?
Incident.
Good. And of course at 6 is jump. Good.
I guess that was before I came in.
Yes. Yeah, the jump discontinuity is this. Infinite discontinuity is this, and removable is this or this.
Okay.
Good. I would like us to work on a problem on page 128. And I just mentioned that problem 23. Let's take a look at it. 23 on page 128. We're given f of x equals x squared minus x minus 2 divided by x minus 2. And we're asked, how would you remove the discontinuity of f? In other words, how would you define f of 2 in order to make f continuous at 2? Yes, I will have to factor first. So then how do I factor the top? Good. So obviously the function is undefined at 2. Otherwise I cannot simplify. I have to write this first. So then I simplify, and then simplified form of this function is x. Very good. So in summary here, I have that f of x equals x plus 1, comma, if x does not equal 2. So for sure this function has a removable discontinuity because x plus 1 is a linear function. X plus 1 is a linear function with a positive slope. But it does not exist at 2. So I want to make it exist at 2. So if x is not 2, then I have x plus 1. But what should I have here so that I define now a piecewise defined function that will be defined everywhere, including at 2?
Does not exist. 3.
Of course, absolutely. So exactly 3. So the reason is this: a function is continuous at a point if the limit as x approaches 2 from the left of the function f of x equals the limit as x approaches 2 from the right of the function f of x equals the function value at 2. So I don't know this, let's say, but I know this. How much will this equal to? Very good. How much will this equal to? Very good. So therefore, how much should that be for the function f of x to be continuous everywhere? Yes.
Was the answer 3 in the original question?
No, we had to determine that.
How did you determine that?
Limit from the left must equal the limit from the right must equal the function
What
value.
it's saying there,
But where are you getting to?
it can't be equal to 2.
So let's find the
It says it
limit.
can't be equal to
We
2.
discussed how we find the limit, right? So please find the limit of x plus 1.
It becomes undefined.
How do you find the limit of x plus 1?
What happens when you plug in 2
Oh,
to x plus 1? Yeah. So when x equals 2, because there's a hole there, we have to fill that hole. So if you kept the graph going, it would go, the next point would be 3, which is why she's saying when x equals 2.
It's a big
It's
ass
a-
hole, but the thing defines that too.
It's just you have to fill in the hole. That's what we're doing right now.
What you were saying?
Saying that it's a big ass hole, but it's at 2. The little thing's at 2.
So when you graph the function x plus 1,
Yeah.
okay, when x is 1, when x is 0, y is 1. When y is 0, x is negative 1. So this is the graph.
Can you move it up?
So this is the graph of y equals x plus 1. But since we simplified,
But with the x is 2.
so when x is 2, there is a hole in the graph. But where does this happen? When x is 2, how much is y?
3.
3.
So therefore, in order to fill this gap or fill this hole, I have to say that my x is 2, I have to define it as being 3, and now the function is continuous everywhere. Which function? Not this. This function is continuous everywhere on the real line.
So that's true, but not that all.
So this will be true in the sense that it's continuous everywhere. We already proved it. This is not a formal proof, but we showed that the limit from the left equals the limit from the right equals the function value at that point.
Well, let's formally prove.
I'm sorry? We proved that it's continuous at that point. But what I really have to quote is this theorem that says polynomials are continuous everywhere, in this case, where they are defined, because this changed into a polynomial function.
But you said that we didn't formally prove it. What do you mean that we didn't formally prove it?
I just showed you the graph and I filled it in, but this is the proof, not this. This is just shows us what happens, but this is the formal proof, not this.
I don't know what you're saying. You said that we didn't formally prove it.
Here, but not here. It's already
Okay,
formally
so
proven.
we did,
Yes, but not with the graph. With the graph, it's not, I wouldn't say that it's a formal proof. It works, but we already
Oh,
wrote
you're
that.
just saying that, like. So
Yeah, I have to state the definition of continuity at the point.
Okay.
And this is the definition of continuity at the point.
That's the proof.
Yes, we wrote it somewhere here. This is the one.
Oh, I thought you were saying that we didn't figure out.
Yeah,
How we,
that's how we determine it. Determine what to write here by using the continuity at the point. The
well,
definition.
I did throw in 2 to x and it become 3. But I did that.
Yes.
And that's how we got the function. X
Yes, but
3.
you still have to write the definition of continuity at the point, not with the graph. You still have to write the definition of.
So,
Say it again.
I might just be being extra.
Okay.
In terms of,
Any questions? Any questions on this problem? Ali, are you okay?
Okay.
Okay, perfect. Moving on then. I would like to look at a situation like 45 on page 129, in which we are given a piecewise defined function, and this is cx squared plus 2x if x is less than 2, and x cubed minus cx for x greater than or equal to 2. We're asked to find c so that this function is continuous everywhere on negative infinity to infinity. So find c so that this function is continuous everywhere.
Maybe if you plug in 2. Where's
So how do we
that's
start?
the whole, right? Is at 2, right?
I don't know. It has a c in it. So I don't know.
So you would set it equal to.
You're on the right track.
Do we solve the inequality?
So the first step, no, this inequality is already solved.
Uh,
In step 1, I have to write that cx squared plus 2x is continuous on the interval negative infinity to 2 as a polynomial function. This is our first step. Is this true? Is cx squared plus 2x continuous?
In an exam or quiz, would you like to write? Should we write it like this?
It's a must.
I don't understand. I mean, these are polynomials, so why would we, it's going to be continuous in essence, will it not?
No, not necessarily.
Oh.
So when I'm asked to find c to show that this function is continuous everywhere, I have to state this. I have to say that this is a polynomial function and it's continuous on negative infinity to 2. That's my first step. I have to make that statement. In number 2, I have to make the following statement. X cubed minus cx is continuous on the interval. Can anyone tell us what?
Positive? Negative?
Comma. Very good. as a polynomial function?
Nine.
No. Step 3, continuity at x equals 2. What do I have to show? Or what is the definition of continuity at a point? Please dictate what I should write as step 3.
You should write both equations and in the middle put x equals 3, I mean x equals 2 and solve it.
Okay, the definition of continuity at a point is right here.
I'm sorry.
It's okay.
Is this the back and forth? Or is X equals this and that?
I have to state the definition of continuity at a point. So, how do I write it? Yes?
X approaches 2.
Very good. Of which branch? Excellent.
1.
Yes. Cx squared plus 2x must equal, very good. Yes.
X approaches to the nine. About the bottom.
Good. Very good. Must equal f of 2. Perfect. So we guaranteed now, we stated a theorem. Here we stated a theorem by saying this. We said this is a polynomial function. It is continuous on the interval where it's given.
Yeah, the right one?
Mandatory. Everything. Yes.
Like the 1, 2, 3.
Mandatory.
Wait,
So I stated the theorem that this is a polynomial function. It's continuous everywhere, especially where it's defined right here. This is another polynomial function. It's continuous on 2 to infinity because that's how it's given to us. What I don't know what happens is I don't know continuity at 2. So I have to make it happen. So can anyone give us the answer for this limit?
would you plug in
I have to.
Two.
That's how we determine limits of polynomials. Yes.
so we c times
Yes? Okay, 4c.
Plus 4.
Yes. How much is this? Very good. And where do I plug in? Which function do I plug into? Oh, absolutely. So this is 8 minus 2c. So then what has to happen for, I'm sorry? So what has to happen for this function to be continuous then? What must I write now?
C equals 2.
Those,
You're way ahead of me. Excellent.
Back to the just
4c plus 4 must equal?
H minus 2.
Excellent. So this is what has to happen at 2 so that the function is continuous at 2. Of course, this is a linear function. I'm moving 2c to the other side, 6c, and I move 4 to the other side and I get 4. So then c equals 4 divided by 6, or 2/3. Yes, Eric, go ahead.
Where'd you get 8 minus 2c? But you didn't use that.
But
It's
they are the
twice.
same.
It's
They are the
okay,
same.
okay, because it was. That was
So
what
any
was equal to.
Exactly. So any question on this?
Wait, so always the middle was the one on the right?
No, it's not always going to be like that.
It doesn't, I have to look at the function. I don't know.
So,
It's
What
only
if-
like that in this case because of the greater than or and equal to sign.
So therefore, the function is, let's go back. Yes, go ahead.
I don't know how you got 8 minus 2c must, or
You have to
2.
replace x by 2. 2 cubed is 8. 2 times c is
Well, yeah,
2c.
No, I get that, but how do we know f of 2 is 8 minus 2c?
Because you have to plug it in where you have equals to.
Wait, f of 2
Where x equals 2, I have to plug it in.
or x equals 2?
It's right here.
Oh, okay. So that's the one that we got.
8 minus 2c.
And what if it don't?
What if it don't what?
It would. Because we're gonna have an equal.
So 2/3 x squared plus 2x for x less than 2, and x cubed minus 2/3 x for x greater than or equal to 2. This is guaranteed to be what? On
Well, actually,
Or
on
X greater than or equal to 2. First equation.
exactly on all real numbers. That's how we made it be continuous on all real numbers. We knew that. Oh, it's
Where does C-
16.
Where does C equals